And we're going to find where that equals 0 because that's the derivative right there. Okay? Or I guess if you want to write y prime equals all that, you can do that too. Okay, now, this is why in the first semester I taught you how to not just take the derivative using pre-calculus, but to use Algebra 1 to factor your answer. You don't want to solve that equal to 0. Okay? I think this is the first day we've ever done derivative equals 0. One of the most important things in all mathematics. I want you to be able to use your algebra skills to factor this. Is there anything in common between group A and group B?
3 minus 1 squared and
2x minus 1 squared, slice and dice, and 3, slice, and who do I dice over here?
3. One without the x.
Either one. Don't take them both out, because if you take them both out, it's a what? 9. Just pick one or the other. Okay? And you can take the one off the x. It's not super good. Well, it's not like cosine of 3x. It is super good. So if you want to take this one, you can take it. Or if you want to take the other one, you can take it. You just take one. Okay? All right. Now, you take that out to the front. Let's see what's left over. What's left over in group A? 2x minus 1. I can drop the parentheses because it's all by itself. Okay? Just draw it. All right. Plus Easter egg hunt. Ooh, where's this, that one? X hiding there. 3, 2, all hiding in the grass. That makes 6x. And now it's time to play one of Mr. Wade's favorite games called Mr. Wade's Farm. Okay? We played this a couple of times in the first semester. Okay? Yes, no Crockett chickens now. All right? Who's going to say, I've got a farm with 2 cats, -1 antelope, and 6 cats? What kind of farm is that? It would be much more logical to say I have 8 cats and -1 antelope, of course. Okay? Collect your like terms. Okay? 2 cats and 6 cats. Come on, just sum them all up here. All right? So I've got 8 cats, -1 antelopes. All right? I'm in the antelope business. Not doing so well. Okay. So you got that, and now let's find the solutions. Okay. Let's first of all find where 3 equals 0. All right? 3 equals 0 when? 3 equals 0. That's impossible. 3 does not equal 0. Okay? If it doesn't have an x, it won't give you a solution. Right? So toss it out. Now, second group. When does 2x minus 1 equal 0? You know why I conveniently just forgot about the squared? If you can make 2x minus 1, it's just the same thing replicated, right? If you can just make 2x minus 1 equal to 0, wouldn't 0 squared still be 0?
Yeah.
So the power doesn't make a difference. So just focus on the 2x minus 1. And x equals what? 1/2. Okay, got that one. And then 8x minus 1 equals 0. That would be, right? Okay, it's kind of like that rational root theorem we did, where we added over, divided. Okay, so you get 2 answers, and we were just looking for the critical numbers, so that's it right there. So the answers would be 1/2 and 1/8. Okay. Now remember what we just found. Make sure this makes sense to you. That's where the derivative equals 0. There are only 2 places. That means not just the derivative is the what again? Slope. So that means that these 2 numbers, they're either peaks or valleys, one of the 2. Now we have to figure out which one's which though, because we don't know it. It could be either one. Okay? Matter of fact, isn't 1/8 just barely past the y-axis? And then 1/2 is actually not that much farther, is it? So what it does, it's a really quick up, down, up, or maybe it's a down, up, down. Okay? We'll find out. All right. So let's answer the next question, and you will see exactly what this is. E. Where is y decreasing? Okay, decreasing. It would be decreasing where the slope is what? Slope is negative. And the slope is the exact same thing in math as the derivative. So actually, you're just trying to find where the derivative is negative. Okay? Here's how you do it. We know where the neutrals are. This is like that one that we did on the homework, number 3, actually. You know where the neutrals are. What happens in between neutral world? You have either positive or negative. One of the 2. Okay? So we are going to do this. Write y prime and make a number. Unlike the homework, we are not testing out the original function above and below the x-axis. We are testing out the first derivative, slope going up or slope going down. Okay? Positive slope, negative slope. Let's find out. Okay? So this is called, you won't believe the name of this one. It's called a first derivative test. How creative. And the First derivative test is one of the most important things you'll ever learn in mathematics, period. Okay? There are so many real-life engineering and accounting and financial analysis problems that are based off this right here. Okay? Tons of them, depending on what field you choose. All right, so first derivative test. Let's mark the one that's a smaller one. Who's small?
1/8.
1/8. And let's also mark 1/2, which is bigger. Okay? And this is, now remember, when you do a number line, it's like an x-axis. And this is the y-axis right here. Okay? So, those are my neutrals, right? This is where slope equals 0 and slope equals 0. And if I pick 0, what do they call it? Sample points, yeah. You pick sample points in between. You can figure, that's kind of obscure. If you pick sample points in between, you can figure out if it's plus or if it's minus. Okay? Now, what is a number that is smaller than 1/8?
1/16.
Okay? You can do 1/16.
Or 0.
0 is an easy one to do. You can do -1,000,000, whatever you want. Okay? It all works the same. What is something that is bigger than 1/2?
100.
Okay? You can use a big one. Yeah, you can use 1, that's fine. The bigger, the more ridiculous it is, the easier it is to plug in. So use 100. Okay? Whatever you want. It's your choice. Okay? Now, we have to squeeze one between 1/8 and 1/2. It's a close squeeze here. Okay? 1/4 is a good choice. Okay? All right, now, let's take these orange numbers here, and we're going to plug them back in. Now, since this is a first derivative test, I wonder where I should put it back into. Gee, I'm testing out the first derivative. I should probably put it back into the first derivative, right? Sure. And let's see, I'm going to put them back in here. Can you imagine taking 100 and putting it in for x there and x there and x there? It's a lot of pain, right? Even here, not that much fun. Look at the factored form. That's nice. We can do the game we did on the homework, which is a plus times a minus times a minus is a plus. A minus times a minus times a plus is a plus, or whatever it is.
Mr. Wade,
Yes?
Mallard Flowers is being dismissed.
Okay.
Thanks.
I said,
Okay. So, let's do this. Let's take 0 first of all. All right. 0. If you plug 0 into 3, who knows what you get? You get 3. There's no x there. If you plug 1,000,000,000 into 3, you get 3. It's unaffected. And 3 is what sign? Positive. Okay? Matter of fact, you can cut to the chase. When you do this test, won't the first one always be plus?
Yes.
Because no matter what you plug in, it's an orange number, it's always positive 3. So just save yourself some time. Just put plus, plus, plus. Okay? All right, now, let's plug in the middle number. All right? All right, now, let's plug in 0, okay, again. So let's see. What about 0 times 2 minus 1 squared?
plus.
Blah, blah, blah. Wait a minute.
It's plus because it's a square function.
You're squaring. Every orange number you plug in, you're going to square the quantity, which is always positive. Save yourself some time. That's plus, that's plus, that's plus. The middle one's always quantity squared. It's always positive. Okay? The only one that changes is the last one. 8x minus 1. Take 0, put it in. What's 8 times 0 minus 1? Negative sign, right? Okay? What about 1/4 times 8? 2 minus 1? Positive. And anything you pick that's bigger than 1/2, okay? 2/3, 1, e, pi, 100. What's 8 times that minus 1?
Bigger.
Definitely positive. Okay? And you get a minus, plus, plus. Okay? Is that, oh, it's a double plus again. So this means, now think about what we're doing. Anything you test out below 1/8 has a negative. Are we on the original function right now or on the derivative? Which one? We're on the derivative. That tells you that the tangent slopes are all going down. That means the graph is doing what? It's decreasing. Okay? So the graph is going down to you get 1/8. Then all the slopes are pointed up, so the graph is increasing. And sometimes you get a false reading. Okay? It's still called a critical number. But it goes to that point, it kind of stalls. Let's say that the velocity kind of stalls out, but then it keeps going up and then picks up speed. Okay? So that can happen sometimes. That's fine. So it turned out 1/2 was not a peak north value. Was it? That occasionally happens. And then what about the 1/8? The 1/8 turned out to be a what?
Valid.
Turned out to be a value. Now you know, because you just went from down to up. And so it has to be a value. Okay? So, final answers. Where is this function decreasing? It will be decreasing from negative infinity
Excluding.
to 1/8, excluding 1/8 because 1/8 is a neutral. And then the last question is, where is it increasing?
1/8 to infinity.
Here's the question.
Well, until you get to the one.
Well, do you do 1/8 to 1/2 union 1/2 to infinity? Or do you breeze right through the 1/2 and go straight to infinity? That is the question. You actually take this one, unless the original function at 1/2 does not exist. Is the original function just a nice normal function that you can plug 1/2 into?
Yeah.
Sure it is, no problem. So keep the 1/2 or 1/8 to infinity. All right, souvenir time.
Where?
Right there. Right.